Welcome to the project demonstration of vehicle tracking system by using LoRa long range wireless communication. So here, without using any internet or without using any Wi-Fi, we are going to communicate the data between the transmitter and receiver. So in this project, this one will act as a transmitter module, so which will send the location of this particular device. So in which vehicle or any object we are going to place this module, so it will get the location from this GPS antenna and to the processor and to the Arduino UNO board, and from there we are going to transmit the data through this long range LoRa module through this antenna, and the same data will be displayed on the LCD screen. So here the transmitted data is received by this receiving antenna and to this LoRa module, and from there to the main processing unit Arduino UNO, and from there the data will be displayed on the LCD screen. So on the transmitter section we will display the latitude longitude values, and at the receiver section the same latitude longitude will be displayed over here, but along with that we will display the signal strength, that is RSSI values also. So whenever the RSSI values is near to minus 100 dB, then that's going to be the maximum distance it has reached. So when it is less than the near to 0, then it has a more signal to communicate without any flaws. So both sections consist of lithium-ion battery, which is of 3.7 volts, and 2500 milliampere per hour is the rating of these two batteries, and these are the rechargeable batteries. So before demonstration, first of all we should keep the battery under full charge. So for that we will provide this two cables. So just connect the cable to the adapter, to this adapter, and then gently insert that into this slot. So then there will be a light indication on this module, so we can see. Right, so it's actually battery is already fully charged, so that's why the light is not indicated. So you can see on this one. Right, so like this the LED will blinks. So when the LED blinks stops, that's the indication of the battery is fully charged. Till the duration we should keep the battery under charging, and as we can see that it's already fully charged. Right, so after you switch on this, you can see that then the light will be indicated over here. So without the power supply also it will work, and these two are the main power switches for this both transmitting and receiving module. So in the transmitter module and the receiving module communicate through the LoRa module. So the best distance for this one is at least of minimum distance you can place near to this, and the maximum distance, and according to this LoRa module ratings it will work up to 3 kilometers as maximum distance, and when we provide the antenna it can up to maximum of 5 kilometers, that too in the line of sight. And if the distance from the ground surfaces increases, means if we place this about 10 meters, so the distance is 1 kilometer, about 20 meters, the distance is 2 kilometers. So like that the distance between these two communication distance will be increases based on the earth level, means distance altitude from the surface of the earth. And if both are line of sight like this, then we can get up to maximum of 5 kilometers based on the height. Like if it is there 50 meters above the surface of the earth, then it can communicate up to 5 kilometers. So without any normal conditions, it can up to work easily for 500 meters, as we have tested that. And the next step is, as we discussed, first step is keep the kit under fully charged, and the next step is we should keep this module under the sky view, then only we will get the exact location values. And there we can see the GPS light will blinks based on the satellite vision. Let us see that. So right, after placing the kit under the sky view, because the GPS will work based on the trilateration method, for that we need satellite vision. So now you can on this kit, so it's on, and here is the on switch. Okay, and welcome message displayed, and at this slot we can see the 00. As of now there is no satellite vision. So when the GPS gets the satellite vision, this particular light will blinks, and here we can see the minus 30 means the minus 30 decibels, that is the signal strength of the receiving and transmission. So when it is near to the minus 100, then as we can indicate that it's more far from the transmitter and the receiver. So let's wait till the GPS will get the signal. Right, now you can see the GPS light blinks over here, and we'll get the location values of present location and latitude values. We can see the light blinking, right? You can see this. Whenever the GPS will get the signal, as you can see, the light will blinks. See that. If we cover the GPS, you can see the LED blinks on this GPS module, and it will get the live location values here. So now let's take this inside the right. So as of now we have increased the distance around 100 meters. So we are getting the values of the same location from the transmitter, and we have increased. We can see the data was changes over here. Means it is decreasing the value. Right. Okay, for every data sending, we can see the light blinking over here. This is the receiver module. So only thing is, if we have the battery in under full charge, then we may get the more distance while we are execution, and we are keeping the near to that module. Right. Right. So as of now we have tested. Now we are charging this transmitter model. Previously it's got full, that's why LED is not blinking. Now it is blinking. Thank you.